pretty soon. Haven't really determined the date on when we might do our next Genius Hour, but not too far from now. Um, Vaishnavi, do you want to say anything else we did on Monday?
I'm not sure. I thought we just made bath bombs and you explained it.
Okay, well, we really didn't make bath bombs. We were mixing the different chemicals. What we were trying to do is see what kind of reactions we got from bath bombs.
Yeah.
Okay.
Okay.
So, let's see here. Aubrey, how you doing today? Oh, wait, hold on one second. Booyah, yes, you may go ahead and add something.
So we were also trying to see what exactly are the things reacting in order to make it fizz.
Right. Very good. So, Aubrey, are you with us?
Yes.
Okay. Where do you think? Yeah, I have a bath bomb right here. Let me go pin myself so the show's better on the video for everyone. I have a bath bomb right here, and for some reason I'm not pinning myself to the video. There we go. And we know that if I take a bath bomb, and that is recipe B, by the way, and I pour some water in here, and I drop it in there, we get fizzing. Where, Audrey, do the bubbles come from?
They come from inside of it because everything is packed together, so
Okay.
the air was releasing itself.
Okay, so what I want to do is I want to test this theory out. Well, technically, the bath bombs we made, yes, you could drink them. Remember, though, this has Epsom salt in it. And if you drink it, what's going to happen is you are going to be spending some time in the bathroom. The Epsom salts, you are able to drink Epsom salt. It's a laxative. A laxative, if you are, well, just be straightforward. If you're having problems going to the bathroom, you can't go to. It will help you do that very quickly. So, yes, you could drink it. You might not like the results, but you could drink it. Okay, so if I take a bath bomb right here, and I take a flask, I'm going to put these on my scale. Put a little bit of water in here. I'm going to put 150 milliliters of water. So I have a bath bomb that reads at 9 grams. I have a beaker that is just under 150 milliliters of water, or excuse me, a flask. I'm going to put this on here. Comes to a total of 256 grams. Why does that not look like 256? That's kind of weird. Oh, it's just, I guess it's backwards. So if everything goes as planned, when I put this in here and I let it run its course, The bubbles are escaping. They're working out. If I look at this, wait, didn't I say 256? And even though that looks completely different, I'm at 255 right now.
Do you think it lost mass from the air escaping?
Did it? Is that a possibility that air is escaping?
I think so because we can see that the bottle got misty, which would suggest air and possible condensation rising.
Okay. That sounds pretty good. So when I did this, I come back just to double check it. 255. So I lost a gram. So does air weigh something? I mean, air can't weigh anything, can it? Go ahead and speak.
Well, it can. If it's like trapped inside, it could weigh it down a bit.
So you mean I'm lifting weight right now? Raising the roof? That's a really bad joke.
You have a lot of air. You need to have a lot of air to actually be able to feel it.
Yeah, and actually, because of our atmosphere, where we're at right now, we have about 14 pounds for every square inch on our body of weight.
Because we're used to it now.
Yeah, we're used to it. Okay, so there's a law. It's called the Law of Conservation of Mass. You might want to write that down. Law of Conservation of Mass. And what this law says is that matter cannot be created or destroyed, only rearranged. Okay. So kind of an interesting, thing to say. But, we need to kind of prove it a little bit. Law of conservation of mass says that matter cannot be created or destroyed, only rearranged. That is exactly right, Sanish. So, how many of you have ever gone and had a big bonfire or gone to, watched fire burn?
Me.
A few of us. So, I love watching fire burn. It's I'm not a pyro. I don't like to go start fires, but especially this time of year when it's not rainy, go out, sit by a big bonfire, roast marshmallows, make s'mores, do whatever you want.
Kind of satisfying to watch the wood like slowly burn, right?
Yeah.
For us, part of our culture to light lamps and to offer smoke for the gods.
Okay. So. Yeah. And I had a woman staying at the Airbnb at my house, and I know she was Indian, and she wanted to passing a blessing on to her mother, and they had a big fire at the house, and they did something with the smoke there as well. I forget what the name of the ritual was, but they had a priest come out and do that. It was kind of neat to watch. All right. So let's just say I'm getting ready for a bonfire. And I bring over about, let's say 100 pounds of wood. 100 pounds of wood isn't actually a lot. It's 8, 9, 10 logs maybe at most. And I clean my fire pit out completely. So there's just, the ground there and the rocks surrounding it. And I light my bonfire. Bonfire is great, burns for 2 or 3 hours. Fire's over. Come out the next morning. I want to clean my fire pit out. And I have about 2 pounds of ash left over. What happened to my wood?
Wait, can you repeat that? How much is there?
Okay, so and go ahead and type any answers you might have in the chat.
Wait, how much wood was there to start with?
So I had about 100 pounds of wood. I burned it, and I was left with about 2 pounds of ash. Now, ash is kind of a grayish black color. It's basically carbon. Okay, Manvitha, okay, experiment with balloons, okay. Merrick, it burned up in the atmosphere. Lily, wood turned into ash. But remember, matter cannot be created nor destroyed. It can only be rearranged. So I can't have made my matter disappear. I couldn't make the wood disappear. Now, the other caveat to this law, the law of conservation of mass, is what is mass? Fire slowly burned away the wood. Everything that could go in the atmosphere went up there, leaving everything behind in the form of ash. That's pretty good. Burned into the air. Okay, so it sounds like you guys are pretty well versed into what's happening. Because if you sit there and you watch a fire burn, you hear sizzling. You might even call it fizzing. Um, we'll come back to that in a couple minutes there, Sanish. So that sizzling, that hissing you hear, it's water. There's water in the wood. Unless you go and you oven bake your wood, called kiln drying, there's water and it's escaping the wood. So I'm pretty sure water has weight. If I take my beaker or my flask and I pour in 150 milliliters of water and I put it on my scale of 200 and it's fluctuating, 257 grams of water. So yeah, water is escaping. We're turning into steam. We already know that steam rises. That's part of the water cycle. It evaporates. But was there 98 pounds of water in that wood? I don't think so. You sit there and you watch fire, especially when you throw another log on it, all these sparks fly up in the air, right? Well, the spark is actually burning pieces of wood. So I have some of that wood escaping. And not to mention the fact that if you've ever sat around a fire, the smoke will drift towards you eventually. Smoke is a bunch of stuff leaving the fire as well, right? So that's little particles of the wood. So we have a lot of things leaving this. So how can I verify that matter is not created or destroyed, only rearranged? Because obviously I know things are leaving my fire, but is it the same? Is it the same amount? All right, let's talk about mass. Samuel, how you doing today?
I'm good.
Good. Samuel, do you know what mass is?
Mass?
Yes.
Is it like the weight of something?
Kind of. Um, I weigh.
Space.
Say that again.
Mass takes up space.
Mass is how much stuff, how much matter is in a given amount of space. And yes, Shrug, there is a difference between mass and weight. Let's just say I weigh 240 pounds. I weigh a little bit over that. But just to make math easier, I weigh 240 pounds. And if I were to hop on my private jet, my private rocket ship, and shoot up to the moon, I would weigh approximately 40 pounds. Has my mass changed?
No.
No. I'm still the same person. I haven't shrank. I didn't get small going to the moon. But like Shrug says, it is the force of gravity. So on the moon, the gravity is 1/6 of what it is on Earth. So I weigh 40 pounds versus 240 pounds. 1/6 of my weight. So we can use the term mass and weight interchangeably here in Bentonville. Because my gravity is going to be the same whether I'm doing an activity in the classroom here, or if I go to your house and we do it at your house, or we go to community center, the gravity is not going to change. Does that make sense? But because this is science, we need to talk about mass. So if the law says that matter cannot be created nor destroyed, only rearranged, I have to be able to have the same mass before my reaction starts and when my reaction finishes. Does that make sense? You didn't really lose it, but you could go around saying you weigh 40 pounds. Only if I'm on the moon. Only say 40 pounds if I'm on the moon. Otherwise, I'm a liar. I don't like lying. So we need to be able to contain everything. We need to be able to account for anything that is slipping off into the atmosphere. So what I'm going to do is I'm going to weigh my flask. I'm going to weigh the bath bomb, and I'm going to weigh a stopper. Let me put this back on me big screen real quick. All right, pinned. All right. So right here, I show my flask. All right. What in the world? I really think I'm technology challenged every once in a while. I'm supposed to be pinned. It shows me pinned. There we go. Now I'm pinned. All right. So I have my flask right here. Has just a hair over 150 milliliters of water. I have a bath bomb, and I have a stopper. altogether, you're looking at my video shows the scale backwards, but it reads 292 grams right now. So I have to do this kind of quick. Let me put this so you can see it. I'm going to take my bath bomb, my stopper, drop it in there. I'm going to put my cork on there. Shake it up. Whoa! Well, that was a fail. I just popped my cork. Hold on a second. Well, I think we just proved something, even though that was a fail. We did prove that the gas is escaping. Did we not? It popped my cork right off there. So I'm going to try this with a little water bottle. So let me, I'm going to get a smaller piece of a bath bomb. I'm going to get a little water bottle. Put my lid on there. So this time we're at 87 grams. We did this with Alka-Seltzer in a balloon. We've done that in here before too. All right, so actually I'm going to add one more thing to this. A tissue. I'm going to separate my tissue. Got the high quality 2-ply tissue in my classroom here. Well, I say I'm going to separate it. Ooh, I lied. It's 3-ply tissue. All right, I'm going to put this up here to see what the weight is. It did not change my weight at all. It's still 87 grams. So, and why I'm doing this is because now I'm going to put my tissue. I'm going to try to smash it a little bit. Put my cap on. Well, I'm not going to put my cap on. Oh, it's going to be difficult with me. Sometimes, guys, I talk to myself. Don't think I'm too weird. Okay. I have a feeling I'm not sealed. I'm not. All right. Plan 2. I did not think this went all the way through. My apologies. All right. We now have switched to a balloon. Hey, what's this? Oh, nice. No, we don't need garlic ice cream. Oh, That actually kind of sounds good. I love garlic. I've drank garlic soda. All right. A balloon that has a bath bomb in it, water. We're still at 87 to 88. Looks like 88 grams. I'm going to go ahead and put the water into the balloon. Really?
Did it work? You might want to put like a rubber band or something around it.
The balloon ripped.
Well, I mean, the experiment is proven though.
Oh, I'm having a great morning, guys. I love Walmart, but their products are cheap. Now I know what I'm going to do. Let me try the beaker or the flask instead. Maybe it was the lip of the bottle that caused it to rip. And then this one. Two balloons stuck together. All right. Hey, do they say third time's a charm? Is that a
Yes,
thing?
they do.
All right. Okay, no holes yet. But if we actually look at this, see where the thing is already getting a little thin? But let's see what we got. Let's try this last one here. All right.
I thought we only use high quality ingredients.
We are supposed to only use high quality ingredients.
I mean, we have the finest tissue paper.
Oh, yeah. I thought Walmart, this is their Celebrate brand. I should have known when I spent 96 cents for 25 balloons, I was not getting the best. Okay, so I have 276 grams with a bath bomb, balloon, water, and flask. Are you guys making fun of me? All right, so obviously we are producing a gas. What was the weight I said? The mass, 275. It's still at 275. So does that show the law of conservation of mass? Did we just prove that we didn't lose anything?
Yes.
Yeah. That one was pretty evident. But now we have one more thing that we have to kind of experiment with. And I believe it was Aubrey I asked this question to. Said that the air, the gas, is trapped inside the bath bomb. Was that correct, Audrey?
Yeah, about right.
Okay. So I'm going to take a bath bomb right here. And I am going to smash the bath bomb. Turning it into a powder. Like Hulk smash. I'm even wearing a green shirt today.
Mr. Cylinder, so basically what happened with the balloon was like the air was trying to escape, so like it was like evaporating, so like it went into the balloon, like making like inflate,
Yeah,
so, like it disappeared.
if we go back into our states of matter, when there is a gas form, it does not like to be around other molecules. It's fast moving. It spreads out. So yeah, a gas will naturally try to escape its confines. Now, if I put a bigger bath bomb in there, the balloon would have got bigger because there would have been more gas. It would still try to get away from what it was in. Does that kind of make sense? Okay. There's high quality balloons. Are we still picking on Walmart's balloons? Okay. We need to get through this here. So I have smashed up the bath bomb into a powder. And I am going to dump it into the beaker. And while I might not have got rid of every teeny little air pocket, I should not have that much of a reaction because I have opened up most of the bath bomb. I actually got a bigger reaction when I smashed it versus when we just dropped the bath bomb in there.
Do you think it's because when you break it off, all the gas escapes, but when it's just like in the big shape, not bricked up, the gas is still trapped in it, so only bubbles in the liquid?
Well, I don't know. This is kind of what we need to figure out. Actually, I should say, this is what you need to figure out. So what we are going to do today is I'm going to put a prompt into Google Classroom. And I want you to tell me, based on the things that we did on Monday and the things that we just did right now, where's the gas coming from? You know, we may not know the answer exactly yet, but I want you to write down what you think you may know. And if you have some evidence based on what we did on Monday and what we did today, write the evidence in there. And then on Tuesday, we're going to come back, on next Monday, we're going to come back, we're going to look at some of these answers together, and we'll start experimenting with some of them to see if we get them true. Rochelle, chemical reaction in science. Okay, that is a very broad term. In the Google Doc that you're going to submit, I'd like you to kind of narrow that down a little bit. Alexa, the bubbles create gas. Actually, the gas creates bubbles. What is a bubble but something filled with gas? Yes, Avinash, black holes have immense amount of mass and matter. It actually, a black hole is what's called a gravity well. It takes matter and it compresses it, and the more matter it compresses, the stronger the gravity gets. I mean, black holes swallow stars. So yes, they have a lot of matter to them. Well, let me put it this way. We believe they have a lot of matter to them. I'm not in your cult, but I love songwriting. Oh boy, we've gone off on a garlic tangent, I see. Okay, give me just a couple seconds and I will have your assignment posted. And actually, if you want to hold on a second. Okay, this is going to be due by the end of day tomorrow. Oops, hold on. Sorry. Week 10, October 27. I cannot believe this month is almost over. Okay, so it is a Google question, and I am asking you to tell me where the gas is coming from and provide evidence if you can. All right, so that is class for today.